じゃあ始めます。Today's content is about the robot for manufacturing. Manufacturing, mainly. So firstly, the various robots. This is one categorization of robot. It's depending on its application. The first one is a robot for manufacturing, assembling task or welding task or something. So it works in the industrial factories. So the productivity improvement and skilled technique usage is required for that kind of manufacturing robot. And also presently the flexibility is very important to manufacturing of a wide variety of product in small quantities. Factory automation, FA, is now, you may know. Factory automation is widely used, but last week I have said the difference of special purpose robot and a special robot to a special purpose automation system and robot. What is the difference? Special purpose automation system to robot. What is the difference? Culture. だからファクトリーオートメーションとか言って、なんだっけ、large scale manufacturing is realized by special equipment to assembling task or something special, but the robot is also used there. What is the difference?
Access maybe.
Access.
Yeah, robot who can work more than 3 axes.
More than access, more degree of freedom, for example. Yes?
I think the first one is for only a certain task, but robots for a multitask.
Yes, the special purpose assembling system is used only one specific task.
Like pressing or something, but robot can do multitasks.
Yes, as I said, end effector. Set the end chip. If you change its tool, or the assembling tool, or spraying tool, or grinding tool, or something, if you change the end chip, end effector, you can use one robot to many variety or wide variety of works, tasks. So therefore, it is different. The flexibility means it is the special assembling system, special purpose mechatronics system is only one task, can realize only one task. But the robot can do wide variety of tasks if the end chip replacement and also software updating. Software is also important to do the wide variety of tasks. So therefore, some flexibility is important for this kind of robot. And the second categorization is robot working in a special environment. It is very hard for the human workers. It is difficult for human workers. Work in place inaccessible, hard accessible for human being. So therefore, it works in space, energy plant, deep sea, and so on. It's a special location, not daily life's location. Okay. So in that place, the robot works in place of human being. So therefore, the workability, reliability, certainty, and so on is necessary. So we ask this robot to carry out that task certainly, surely. So the workability, reliability, and so on is very important for this kind of robot. And third categorization is social support. For example, one is the public support, and the other is individual support. For general public, the mobility, medical welfare, and personally the home assistance or something. In this case, these robot works close to the people. Human coexistence environment, it is called. So therefore, the safety is one important point for this kind of robot. まあ、オートノミーとか、セルフコンテインとか、まあ、some kind of intelligence is necessary. So maybe you can understand the robot works in the variety of places, but the important technology is depending on its application. Different technology is required, important for depending on its applications. で、today's talk is about industrial robot. Yes. This course, I will introduce these categorized robot step by step. But first part is about the robot for manufacturing today. Okay? Mainly industrial robot. Because the commercially available robot is industrial robot. Especially in automobile companies, automobile manufacturing company is a consumer, very important consumer for industrial robot company. The beginning of a modern robot is about the middle 20th century, because after the World War II, the robot is become widely used. What is the background? Three important points is there. One is computer technology development. The upgrading, speeding up of calculations using large amount of memories, and these memory chips cost become decreased. Price reduction is also important. So we can use the computer easier. So therefore the robot is controlled by using the computer. So therefore the computer technology development is very, very important asset of the robot usage. Second is automation. Yes, factory automation. The progress in automatic production technology for power saving, mass production, development of numerical controlled machine tools, and so on. So therefore the automation. For mass production, yes, only for the mass production, specific purpose assembling system is also used, but presently the consumer's requirement is very, very various, wide range. So therefore the wide range of products the manufacturer should prepare. So therefore the industrial robot is used for adapting this wide range of requirements. Thirdly is the development of nuclear technology. One important point for after the World War II, the nuclear energy is used for the energy source. But you may know the nuclear material is very, very dangerous for human being. So, but we have to handle these materials, radioactive materials, in place of human workers. So the robot is used. These three background is there to realize the robot. This is a short, brief story about modern robot. One, これは1926 is the Maya. Or Westinghouse, presently very famous Westinghouse. Westinghouse Electric Corporation, Lovejoy Wensley is developed this remote controlled robot. Robot, but it's only it is only moving its arm up and down. By using the voice signal via the telephone circuit, yes, in some remote places, someone is making the sound by whistle. Each sound is telecommunicated by using the telephone line, and this robot can raise his hand. Okay. This robot is made. And Eric is here. Eric is a robot, humanoid robot. This is a United Kingdom's person. Greeting with standing up from chair. Yes, usually it's sitting on the chair, but someone coming here and standing up, and some greeting gesture is there. Is he made? And the same year, the Japanese scientist Makoto Nishimura made the gakutens of this robot. This robot, left and right arms movement with facial expression with bi-motor power, it is said. But it is not remaining presently. It is broken during the war period in Osaka. And 1949, after the World War II, the mechanical master-slave manipulator Model 1 is made by Argonne National Laboratory. This is here. This is a slave arm, this is a slave arm, this is a slave arm, and mechanically connected. The master arm is mechanically connected to the slave arm. Slave arm is handling the radioactive materials, and this is here is a wall, protection wall is here. The human worker is operate this slave arm, and through this glass, this slave arm's operation is watched by this human worker, human operator, and this radioactive material is handled. Yes, this is mechanically connected, this slave master arm and slave arm. Master slave っていうのはマスターアームはなんかオペレーション to command input via the master arm by human, and slave robot do some actual work だからコマンド and なんかフィードバックシグナル。Master slave is one remote operation method technology です。これはだからアルゴンヌナショナルラボラトリーって one of the nuclear technology research and development laboratory in United States. So therefore they have developed this master slave arm to handle the radioactive materials. で、1954 Programmed Article Transfer Machine っていうのが This is US patent number this by George DeVol is offered this patent. This is very important patent for industrial robots because teaching playback system is represented in this article as a basic movement control of industrial robots. で、ASIVA. What is a teaching playback? You remember?
Maybe the robot is doing this to do some tasks.
Yes.
So,
teaching プレイバックもうちょっと more exactly what is a teaching what is a playback
So at the first time, robot teach by maybe some to do some gesture or something,
Yeah.
and after that, robot can do the exact same thing.
Yes 例えばなんかロボットがこのオートモビールのなんかここにまあなんかこうロボットがいてなんかここにスプレーガンでペインティングタスクしますよとかいうときに this trajectory is taught firstly by using the なんか direct teaching method by the worker holding the end chip and following this trajectory or some worker is doing some teaching pendant the command input system for this robot trajectory is coded by using some devices and then this movement is recorded by memory recorded in some memory これは teaching phase ね teaching phase is the movement is taught by using directly by using some command input devices programmed this movement is stored at some memory. This is teaching phase. The playback phase is the robot read this memory and repeat this movement. This is playback. So therefore, the teaching playback is a basic movement control technology for industrial robot. So firstly, only movement is taught and movement is playbacked, represented again and again. So therefore, this patent is very, very important for industrial robot. でこれジョージ・ボールはこのユニメイトをユニメイトバーサトラン is the first two industrial robots in the world. Unimate by Unimation Incorporation, Versatron by AMF, American Manufacturing Foundation. I remember. Both United States company has announced these two industrial robots commercially available. で、ジョージ・デ・ボル is one of the founder of Unimation Corporation. ちょっとこれ見ますか。ジョージ・デ・ボル Inventor of the first industrial robot っていうのちょっと見ますか。はい。ね。
In the early 1950s, most Americans were captivated by imaginary robots. George DeVol was inventing the first real one.
To try to get a normal businessman to understand the robot, they thought you're talking about science fiction or something like that.
A prolific inventor, DeVol had already introduced the world to the Phantom Doorman, the first automatic door. But his 1954 patent filing opened the door to what DeVol called universal automation, which led to the world's first industrial robot. The patent was the easy part. Finding a business partner seemed impossible until DeVol met entrepreneur Joe Engelberger.
Talking about it, that sounds like a very good idea. I think the patent makes sense to me.
The two men formed Unimation, the first robotics company, and in 1961 introduced the world to a new kind of worker.
Automation's newest contribution. This jack-of-all-trades robot is called Unimate, and it handles dull, difficult, or dangerous jobs with equal aplomb.
Weighing in at 2,000 pounds, Unimate's flexible mechanical arm was powered by hydraulics, its memory a large magnetic drum that enabled it to master dozens of different operations with its end effector, or robotic hand.
End effector is another word for tooling. Now, the tooling can get pretty sophisticated.
because some of the tooling has sensors built into the clamp, let's say, that will allow it to exert just so much pressure on something.
Unimate could grip, weld, drill, and spray. But company executives were hesitant to commit, and workers initially afraid of losing their jobs.
Robot had one thing advantage immediately, and that is the robot could work between shifts and work 24 hours a day.
But eventually, executives saw the competitive advantage of robots, and workers found thousands of jobs in making them. Today, industrial robots perform millions of applications throughout the world. Once science fiction, George Devol's vision is now the very essence of industrial and scientific fact.
っていうやつでした。まあこれはね、ユニメイトっていう会社を作って、he established a Unimate and the Unimation で Unimate is one name of the industrial robot で、ここにパワースーツ、ハーディマンって GE ジェネラルエレクトリックがカンパニーがこういうなんかエグゾスケルトン arm is developed in this. This is a whole body, the supporting exoskeleton type power enhancement robot is also recognized. And then in 1971, Japan Industrial Robot Consortium, presently is a Japan Robot Association, JARA, is established. And 1980 is called first year of robot in Japan because in many manufacturing companies used the industrial robot so much. So it is called the first year for robot, 1980. And then the 1983 Robotics Society in Japan, Academic Society is also established. This is some association between manufacturers, users and manufacturers. This is Academic Society is also developed, founded. It's like this. で、ここには Industrial Robot Classification があって、there are mainly 4 types of industrial robot is there. One is a cylindrical robot, second is a polar spherical robot, third is a Cartesian rectangular robot, third is an articulated anthropomorphic robot. これが、シリンドリカルロボット。これスフェリカルロボット。これがレクタングラーロボット、カルテシアンロボット。And these three is the articulated robot にカテゴライズされるけど、mainly vertically articulated type is here. ね。で、これなんかローテーション1、トランスレーション2とか、ローテーション2、トランスレーション1、トランスレーション3、ローテーション3とか書いてあるんですけど、What is this? Dhamma.
Degrees of freedom.
Degrees of freedom. What is degrees of freedom?
For every robot, which axis can he move in freely? For example, the Cartesian robots or the Cartesian robots move in X, Y, Z.
Yes.
Or the polar robots move in 3 rotation around X
Yes.
and Y and Z.
For
example.
Yes. 1 plus 2 is 3. 2 plus 1 is 3. This 3 and this 3. Why it is 3?
3 degrees of freedom.
Yes. 3 degree of freedom. 3 degree of freedom, of course. 5, 3. 5 is 3.
The other 3 directions of movement are constrained.
Nani? What?
The movement in the other three degrees of freedom, like the cylindrical robot, translation in the z-axis is constrained. It cannot move.
It can move only in those 3 directions.
Yes.
Move 3D move. To observe 3D move.
3
まあまあいいけどさ、カルテシャンコーディネートだったらこうだよね。3 ディメンショナルカルテシャンコーディネートで XYZ で3 degree of freedom. What is the meaning of 3 degree?
The working area.
The 3 dimensions is freedom, is a degree of freedom.
Each degree for each robot have a working area, working space that he could reach. So to cover this,
Yes. だからね、それは one point in 3 dimensional space
yes,
is 3 degree of freedom.
To be able to move like
でしょ
that and
で、だから
reach the point.
pointing end tip. Yes, this robot is using the pointing in the space, in space, 3 dimensional space. These all 3 degree of freedom is used for the this position's pointing in the 3 だからpositioning, location, localization or in 3 dimensional space. So therefore, this robot using the yes. One rotation, two translation. These 3 degree of freedom is used this positioning. Yes, the polar sphere robot is this rotation and this axis is rotation and this axis is sliding movement. Yes, 2 rotation, 1 sliding movement is used to this point position localization. Okay, the 3 degree of freedom used in the positioning of these places, positioning in 3 dimensional space. And the Cartesian coordinate robot is 3 linear sliding movement is used for this position's localization, positioning. This articulate robot, 3 rotation, 1 basement movement, second axis rotation, third axis rotation is used to this point positioning in 3 dimensional space. So therefore, all these 4 kinds of robot has 3 motors, 3 degree of freedom, 3 axis, 3 joint. Okay. So it is categorized like this 4 types. Okay. So this is these 4 types is modeled like this. So this is a cylindrical type, rotation, linear movement. The end tip is here. And this is a spherical type, rotation around here and rotation this axis and linear movement. The end tip is localized here in 3 dimensional space. And this is a 3 linear slide is 1, 2, 3 linear slide is positioning this point maybe. And this articulated robot is basement rotation, this angle is swinging up, swinging down, this angle is swinging up, swinging down. So therefore it is modeled like this, symboled like this, and this position's localization. Okay. はい、です。で、だから、basic structure of industrial robot shows the robot list positioning. 3 degree of freedom robot. 3 joint robot. Okay. 4 category. This is also you should remember. Yes. I will ask next week. Okay.
Please ask.
Please ask. Yes. Okay. Yes. Yes. これバーサトラン。Yes. I will introduce バーサトラン and Unimate. These 2 slides. Yes. As I said, バーサトラン and Unimate is the first 2 industrial robot commercially available. Yes. the Versatran, American Machine and Foundry Corporation, developed. Harry Johnson and Giorgio Milenkovic is founded this company. Yes, as you see, this basement rotation and linear slider and do some task like this. This robot is versatile means versatile transfer machine. Versatile transfer machine. Various kind of work object can grip and transfer anywhere it means by using this kind of movement like this. So hydraulic system. So therefore it is a main body, but the oil pressure system is necessary to work. The programmable memory device with a control circuit. The payload is about 20 kilograms. This is very heavy equipment, but it can work, it can hold the 20 kilograms at that time. In Japan's agency is Daido Steel Corporation. これ名古屋ベースカンパニーですね。これなんかいいスキップ。Second is Unimate. Unimation Corporation はジョージ・デボルト・エンゲルバーガー here. Joseph Engelberger has died about 2 years ago, 1.5 years ago, up to the 19 years old. で、5 degree of freedom. じゃあなんかここはbasement and swinging up, swinging down, and this third joint is linear movement. And wrist joint, wrist 2 joint. After expansion, contraction, and rotation, wrist bending and twisting. So the totally 5 degree of freedom it has. So this part is for the wrist positioning. This part is used for the wrist direction, orientation, definition. Payload is about 45 kilograms. This is also worked in the pneumatic actually, oil pressure. 200 kind of basic movement is stored in the memory. The Japanese agency is Kawasaki Heavy Industry. Kawasaki ね、Kawasaki Heavy Industry. ちょっとどっちがいいかな。
Automation's newest contribution to man. This jack-of-all-trades robot is called Unimate, and it handles dull, difficult, or dangerous jobs with equal aplomb. His electronic memory helps him learn up to 200 separate movements. He has muscle, can pick up 75 pounds, and can stand extreme heat, cold, noxious odors, toxic gases, and radiation. He's accurate to 0.05 of an inch, not exactly sloppy, like perfect for heavy work or labor which may invite injury. Unimate is displacing 10 men at a time who are retrained for better jobs elsewhere in the factory. He costs $20,000 or rents for $7,000 a year. He never complains, asks for a promotion, or demands a pay raise. He doesn't break, bend, or burn, and should make some other Unimate a perfect husband. Or maybe wife.
はい、というわけで、これはこういうイメージの話だし。ちょっと、エンゲルバーガーの If you want to see the Engelberger's video, you should access later at this. Okay? And in the previous video saying the American workers is not welcome the industrial robot because the robot will yes, it is used for in place of the human worker, they think. But in Japan, this kind of robot is welcomed. I don't know why, but they also work with them, and for example, in the automobile assembling line, they put the nickname for each industrial robot. For example, and at the time idol, or at the time of the anime character, manga characters, put on it, and then the
robot's names.
yeah, not to the real robot name. For example, the なんかドラえもんとかなんか some the picture is put on it, the Doraemon face is put on it, and then it called Doraemon as like this. So this kind of attitude is made by Japanese workers in Japan factories.
So they love it.
They welcomed because of it released from the heavy, dangerous tasks. So therefore, they have welcomed all these industrial robots. Yes, various industrial robots there. For example, in Japan, the Yasukawa Corporation, Kawasaki Heavy Industry, and the Fanuc Corporation is famous in this field. And also the Acer Brown Bevely. Yes, this is a Switzerland company, but the Acer is basically a Norway company. And Brown Bevely is maybe a Switzerland company, and joined afterwards. And Kuka is a German company. Yes, for example, this is a Yasukawa Corporation's industrial robot lineup. There are many kind of robot is there. I said the industrial robot is used for various kind of tasks, but of course it is especially for some assembling task, or some, for example, the welding task, or sealing task, or some handling task or something. It is also safe. ちょっとこれなんか展示会のロボット見ますか。あ、ダメだこれ時間こない。すみません、これ時間の無駄でしたね。はい。You should access later. And this is Fanuc. Fanac's lineup looks like this. Small size. これ this axis shows the payload. What is the payload?
Maximum weight carrying capacity.
So the weight it can carry in any postures. So the easiest one is close to the body, but the most serious position looks like this, expanded, but it can carry. For example, the more than 1 ton these robots can carry. Yes, more than 1 ton these robots can carry. But the size is very large, of course. そのarticulated type, and sometimes this is gantry type. Frame is there, and the robot is hung from this gantry, this frame. And also parallel robot is there, and this is also one parallel robot here. Okay. ちょっとここなんか見ますかね。これは花子の方がまだ見たい。これいってみるか。ハングリー。
A Faludt cég robotjai és gyártás technológiai megoldásai már 60 éve segítik az ipari termelést. 120 országban vannak jelen, így Magyarországon is, ahol a húzóiparágban az autógyártás területén segítkeznek. Többek között az Audi Hungária Motor Kft-nél Győrben, ahol az Audi AG és a Volkswagen koncern telephelyei számára fejlesztenek és gyártanak motorokat. Az Audi Hungária Magyarország egyik legnagyobb árbevételű vállalata és exportőre. 2014-ben közel 2 millió motor, illetve több mint 135 000 jármű gördült le a gyártósorokról.
A Faludt robotok az eddigi tapasztalatok alapján megbízhatóan működnek nálunk, a termelékenységet folyamatosan javítjuk, a céljaink eléréséhez ugye üzembe helyezik a robotokat, ahogy nagyobb nyomással, hőmérséklettel dolgozunk, ott a robotok gyönyörűen kiváltak azt a feladatot, amit ember munkálat tulajdonképpen nem is lehet ebben a minőségben elérni. Tehát alapvetően a robotok ugye végzik el, amit nekik ergonomikusan nem olyan kényelmesek, vagy ütemidőben nem gyors lenne nekik, és ez a kollégáknak tényleg megkötő munkát. Mivel egyik legfontosabb a robotokkal kapcsolatos, hogy jól állítsuk őket, jól megtanítsuk őket működni. Alapvetően nem a robotok szoktak önmagukban koordinások lenni, hanem hogy valaki nem megfelelően tanítja, vagy nem megfelelően alkalmazni. Illetve amit kiemelnék, hogy a programozásuk alapvetően megbízhatóan működnek, stabilan, és nagyon pozitívak a tapasztalataink.
はい、というような感じで、This is パナックと、これ、アウディ・ハンガリーのマニファクチャリングファクトリー、explain です。で、とこで、How cars are built ですけど、このだから例えばこの黄色いイエローロボット is mainly the パナックロボット。なんかオレンジロボット is クーカー or something。これ This is Unimated robot。Kawasaki FE industry. So you can understand if you visited the automobile factory, various kind of a robot has used. Yes, sometimes it's a cylindrical type, sometimes it's a spherical type, sometimes it's articulated type, like this, and country type is also used. So you should well, this is today's subject. You should watch this movie. For example, this Nissan's video is very interesting because it follows the process of manufacturing clearly, and you can understand how car are built. So through this assembling, the manufacturing, the many kinds of robot is used by watching this video. So therefore, you should listen and you should explain which kind of robot, which kind of payload, which kind of end effector is used or something. So これさっき BMW のビデオは I have shown in the before this class, and you should show this Nissan video. ちょっと5分 about 6 minutes. これは maybe you should watch later. Okay.
どこで見るの？このビデオはどこで見るの？
これはここをこの PDF ファイルがアップロードされてるから、PDF ファイルのここの部分をコピーしてどっかの Google とかなんかで検索するとこれが出てくるし、ここにちゃんと書きました。YouTube の番号を書きましたから、ここにアクセスすると English version, Japanese version. This is the same video. Either one is okay. You can access later either one. And which kind of robot is used for some assembling process or manufacturing process, you should list up. Okay, this is today's subject. です。なのでちょっとこれは今スキップしますけど、後で見てくださいね。あと20分しかないので、ちょっと残りの部分を説明します。Okay, remaining part will explain in 20 minutes. で、これは、yes, this is only single linear guide. Is also called robot. ね、シングルアクセスロボット。これはヤマハモーターカンパニーズプロダクト。And this is IAI. This is IAI is also the Japanese company. Yeah, single axis is also called robot. And the one parallel robot is presently, it is very widely used in assembling, manufacturing, or some companies, factories. What is the difference? What is parallel robot? You understand what is a parallel and what is a serial? Dama, what is a serial robot? What is a parallel robot? Serial.
Serial robots?
No, serial robot. Parallel robot. What is the meaning?
I can only guess.
Yes, okay.
It makes serial operations.
Operation?
No, I don't know.
I think it is about the links.
Movement.
Links like
Links, yes.
links
The links,
series.
the serial connected, link joint, serial connected robot.
Yes, parallel in the links are in parallel.
And the chip looks like this. This is serially connected. So the many industrial robot is, many robot is looks like this. Link joint connection, serially. And parallel robot is, the end chip is here. It is supported various links and robot, and joint. This end chip is supported by parallel links. This is called parallel robot. Okay, so this is one parallel robot. This end chip is supported by multiple link structures. What is the difference between these? What is the feature? Serial connection robot, parallel robot.
I think serial is limited somehow, maybe in power and
Payload. The payload is high.
yes, some constraints.
This is
Limited.
これね、だからメンバーあります。これthis is supported parallelly, so therefore more large amount of payload can be made.
But I think the serial one is more degree of freedom.
More degree of freedom necessary for parallel.
Same for the serial. Serial one is have more degrees of freedom.
And the robot itself must be.
You can.
何ですか？
Okay,
これ6 degree of freedom だったら6 degree of freedom movement can be achieved for the positioning and orientation. The position 3 degree of freedom, 3 orientation. Yes, and also if it has 6, 1, 2, 3, 4, まあいいや、なんか5, 6. If it has a 6 degree of freedom, it can also doing the 6 position, 6 orientation can be controlled. Yes, of course. So in this condition, what is the difference? What is the special feature? Yes, it can work more larger payload can be carried by supported by serially, and what?
I think if one joint is broken or something in the serial, maybe the whole arm or the whole robot is affected.
One important thing is working area, because this serial connected has a wide range of movable area, but to the parallelly connected, so the limited space, only the limited space it can work. Yes, serially connected arm has more wide movable area and more. Yes, the payload is larger, yes, but the movable area is larger here. Payload, movable area. What is the third one?
Flexibility? Oh, flexibility is really the.
Yes, flexibility is a wide range area. Yes. Yes, you said?
Complexity.
Positioning. What is the positioning?
Positioning of the end effector.
Yes, positioning of the end effector is nani? What?
easier in the serial.
Easier.
More acceptable, more achievable.
This one more balanced, I think.
Better. What's the meaning of better?
Balance.
Accuracy.
Balance.
Balance.
I think accuracy.
Yes. The accuracy, positioning accuracy is
high.
because higher, because it is supported parallelly. So that this point positioning precision will become higher. This is serially connected, wide range, but it is
Control is very high.
it is very looks like this. So long rod.
Yeah.
So it is difficult to control this position precisely. But parallelly supported, so more precision. Okay? And yeah. Then this is my general features of serial and parallel. But honestly, this parallel robot is used for rapid pick and place. Food instance. Bread. Sausages. For packaging, it is aligned. Maybe using the image processing and some amount of size or something should become same by multiple number of sausages. Yes. For image processing. The planning or the boxing. So therefore you may understand not only the assembling or some kind of automobile companies, but also this kind of food company is presently a good consumer for industrial robots manufacturers. で、あと10分ぐらいなので、ちょっとこれは今スキップして、Dual Arm Robot is presently, so it is designed for human to coexist with human being, so to liberate human being from manual repetitive labor. Yes, this kind of robot is developed. And also MIT's Baxter is very famous, smart, soft, safer, new industrial robot worker. But this kind of feature you may estimate this is completely replacement of human work. Yes? Let's skip this. And finally, AGB です。AGB ね。This AGB is maybe you know some kind of not only the mobile base but also the manipulator is also on top of this AGB basement movement. But you can understand that automated storage is building is also one robot. Building, retrieval system. This is also the one stock yard is also the robot. ちょっとどっちか。これでも見ますか。
BMH, experts in the full range of automated storage and retrieval technologies. Automated storage and retrieval systems are rapidly changing the landscape of product buffering, distribution, and order fulfillment. Today's solutions provide the flexibility to handle a wide variety of product profiles with exceptionally high throughput. That's just advanced design techniques for mini-load, unit-load, deep-lane, and automated cart flow applications provide the reliability and throughput you are looking for. ASRS solutions provide cost reduction through reduced labor and exceptionally accurate order picking. Many of the newer ASRS solutions emerging in the market today, like this tunnel cart flow concept, are especially cost-effective through automated replenishment to the forward-way locations. To ensure real-world success, BMH's experienced engineers develop 3D graphical simulations using your actual order profiles as input to validate actual system performance. BMH integrates full material handling systems, providing a complete turnkey solution. Please give BMH a call today to discuss your custom AF.
まあいいや、今このビデオだったんだけど、このビデオはmore recent video. And also you may understand the hospital, the drug storage and collect drug is medicine is very important work for the hospitals. So the picking up.
My name is Cindy Silva and I'm a pharmacy technician. I've worked in pharmacy for almost 5 years and I've worked at St. Joe for 2 of those.
So the storage system, picking up system is also used in the large scale of hospitals.
Using box picker to pull fills and take medications up to patients.
What I like about box picker versus the carousel or even an open shelf system is that the efficiency is wonderful. From the standpoint, I can have 2 or 3 operators in my box picker at the same time doing 2 or 3 operations.
Maybe you may, if you are interested, you should access later. And finally, this is a warehouse maintaining system. Is maybe you know the Kiva system, especially in the Amazon stock offices. The Kiva system using the mobile robot unit and human picker, parcel. So this, for example, inside Amazon robot human assembling line, I will show this.
Hey everyone, it's Leah Steinberg with Commander.com. Everyone knows that Amazon's motto is shipping everything from A to Z. But do you ever wonder exactly what it takes to get millions of their products packed and shipped every single day? Well, in this exclusive video from Commander.com, we'll take you inside one of the fulfillment centers to find out how it's 28 football fields. Over 15 million items are stocked in this facility every day, and the endless rows of jumbled consumer goods looks like there's no method to this mind-blowing madness. But Amazon spokesperson Ashley Robinson told me that's definitely not the case.
That process is called random stow, and what will happen is the associates will look for places that that particular item will fit into it a bin, and it doesn't necessarily have to be next to the same item. We prefer it to be very random.
You got that right. I found this power juicer stored next to some Dial soap, followed by this huge tub of Big League bubblegum. With over 2,000 full-time employees at this facility, online shoppers who click buy immediately alert handheld technology scanners that tells associates where to retrieve the product and then uses an algorithm to send employees to the most optimal next item to be picked. But if you think that's impressive, Amazon's busiest employees are actually their Kiva robots.
Their strength is equivalent with an NFL linebacker. They weigh over 300 pounds, and they can lift up to 750 pounds. In a fulfillment center where we handle larger items, those particular robots can lift up to 3,000 pounds.
Now the products travel in these yellow boxes called totes through 8 miles of sky-high conveyor belts until they reach another incredible technology called the SLAM line, which stands for shipping, labeling, and manifesting. This bad boy actually already knows how much your product should weigh before it ships.
So if it sees that the book you ordered is not weighing as much as it should within the computer system, it will pick off that item to the side, and the associate will pick it up and address it and make sure that the right item is sent out the door.
Now it's finally time for the packages to head out the door and ship to your door. The boxes are pushed down metal chutes that are separated according to shipping preference. Workers are then challenged to a game of Tetris as they have to pack the items tightly together, wasting no space.
And get this, on Amazon Prime Day, which was the company's 20th...
いや、これはなんか今の Amazon のウェアハウスのことなんで、ちょっとキバシステムのイントラクションのビデオはちょっと little bit old, but I will explain fast. Sure. At the beginning, only a beginning part.
Uses a breakthrough new approach to order fulfillment, one that simultaneously improves productivity, speed, accuracy, and flexibility. With the Kiva mobile fulfillment system, the operator stands still, and products, cases, items, or orders come to them. Pallets, cases, and orders are stored on inventory pods that are picked up and moved by a fleet of mobile robotic dry units. The distribution center is now completely dynamic, self-organizing, and self-adapting. The first step is restocking. A pallet of products arrives in the building and must be put away in the picking area. With a typical solution, the worker must find out where the location of each of these cases is in the distribution center and wander out into the warehouse to manually place them back into their racks. But with Kiva, when the worker scans the inventory for replenishment into the system, the drive units immediately begin moving to bring the correct pod for replenishment. The worker will not move from this spot to replenish all of these cases. By eliminating operator travel, Kiva increases productivity. In addition, since the system dynamically calculates the optimal location for replenishing the product, Kiva eliminates the need to analyze and reslot inventory. Once the inventory is in the systems, workers can pick items to fill customer orders. Part of the Kiva mobile fulfillment system is a server that is integrated with the customer's warehouse management system. This server receives the customer order and assigns it to a picker at a station. These orders will be filled in real time, unlike other systems that require batching orders together before they can be filled. As soon as the order is assigned, drive units are dispatched to retrieve the inventory required. Each worker is supported by 5 to 10 drive units that will line up and wait their turn to be picked. The worker stays in one place and lets the work come to them. As a result, each worker can produce 2 to 3 times as many orders per hour. The first pod to arrive is the shipping pod. This pod holds the box that will be shipped to the customer. Each pod has several orders on it, which means that the pick worker is filling several orders simultaneously. After the shipping pods arrive, inventory pods arrive, and a laser pointer illuminates the item to be picked. Because of this very simple user interface, the Kiva system requires little or no operator training. The worker picks the item and scans the barcode to confirm it is the right item. If it is correct, a light will come on to tell the worker which order to place the item into. This scan is one reason that quality with a Kiva system is higher than other solutions. Every item is checked by the picker. After the worker places the item, they press a light to confirm they are done, and then they turn to pick another item. By the time they turn around, a new pod has arrived, and a new item is ready to be picked. After the item has been picked, the drive unit returns the pod to storage. The location it goes to depends on the item. Fast-moving items are stored near the workers, while slow-moving items are stored further away. And the storage location is adaptive, not permanent. As the speed of the item changes, the location will change.
というわけで、ピッカーはスタンドスキルで、これはボックス、インディビジュアルカスタマーズボックスで、このストックが is bring by this mobile robot system. And so therefore she is doing the multitasks parallelly and picking place. And this stocker is come here and go back to some stockyard. And this distribution is controlled by computers. This system is a Kiva system.
Once all of the orders on a shipping pod are complete, that pod leaves and is replaced by another empty pod. The completed orders are now ready to move to the shipping door and be loaded on a truck. As soon as the dock door is ready, the shipping worker indicates which truck they are loading, and all of the appropriate orders are retrieved. The worker unloads each box from the pod, takes it shut, and loads it onto a pallet for shipment. Because all of the orders are mobile, they can be brought to any dock door at exactly the right time and in whatever sequence the customer requires. Traditional sortation devices have a fixed number of buffer locations, but the Kiva system allows unlimited sort by simply adding drives and pods. With Kiva Order Fetch, distribution center operators can triple output per worker, reduce order cycle times to minutes, and load trucks at exactly the right time, all with a system that is quick to install.
というやつで、まあいいや、というやつでした。はい。というようなものが、まあ、これなので、ちょっと、if you are interested, Kiva Warehouse Robotics History Channel とビデオとかありますか？なんか言う。If you are interested in more, you should access later. Okay?